Good day, everyone. In this exercise, we have a 1.5 kilogram of an ideal gas that has undergone two processes. The first process was a constant volume, and the second one was a constant pressure. Now, this is a clearly defined state, unlike the previous exercises we solved before about the piston with stoppers. In the previous exercises, we have to analyze to see whether there was an intermediate state or just a simple two-state. However, in this question, it was clearly stated. So we have a state number 1, where we have 150 kilopascal, and we have T1 of 300 Kelvin. This has reached state 2 under a constant volume, and the temperature at state 2 is 1000 Kelvin. Then this has gone through a constant pressure process, P3 equals to P2 in this case. Temperature 3 was given as 1500 Kelvin. So to explain this in a P pressure V volume diagram, we have a constant volume process between 1 and 2. This is 1, this is 2, and then a constant pressure between 2 and 3. So what we need to find is V3. Because this is an assumed ideal gas, we can do ideal gas law ratio between state 3 and 2. Because this is a constant pressure process, so if we divide these two relations, pressures will cancel, and this is a mass, and the ideal gas constant will also cancel. We end up with a relation between temperatures and volume. We already have the T3 and T2. We only need to find volume at state number 2. Now, according to the given, volume at state 2 equals to the volume at state 1. So if we find the volume at state 1, then we will be able to find volume 3 straight away. Volume 1 can be written as mass RT1 based on the ideal gas law. Implies volume in state 3 calculated So now we need to calculate the work in the process, and the work can be found, which is the area, under the process 2-3. We know very well that the pressure given at state 1 is 150 kilopascal, but this is no use for us because we are looking for pressure 2. If we know the pressure 2, this means we know the constant pressure that this process is occurring at, and then later we can find the area. So we need to find pressure 2. Applying the same procedure, making the ratio of the ideal gases between state 2 and 1, we can find out P2. Doing the ratio, we end up with P2 equals to P1 T2 over T1, which is 150 kilopascal this is equal to 500 kilopascal. So we can say that the work total is the work between 1 and 2. This is 0 because volume is constant, plus the work between 2 and 3 where the pressure is P2, 500 kilopascal. So this equals to P2 of volume 3 minus volume 2. This is 500 kilopascal. And volume 3 was calculated, which is the final volume. And the total work is a positive quantity because it produced a useful work causing the expansion as shown in the previous PV diagram.